A flying power plant has just gone live. A flying power plant has officially been connected to the national power grid in China, and it could redefine the future of clean energy. This marks the world's first high-altitude wind power system to successfully deliver electricity to a national grid, opening new possibilities for renewable energy, especially in areas where traditional wind farms are difficult to build. The world's first high-altitude wind power system. The system, known as S2000 Southwest, is unlike any conventional wind turbine. Instead of being fixed to the ground, it is a massive aerostat-based platform, combining a giant wind turbine with a large helium-filled airship. The structure measures approximately 60 meters long, 40 meters wide, and 40 meters tall. About 197 by 131 by 131 feet. Unlike traditional turbines that operate close to the ground, this system functions high in the atmosphere, where wind is stronger, steadier, and more predictable. The test flight that made history during a recent test flight in Sichuan province. The flying power system reached an altitude of 2,000 meters, about 6,600 feet in just 30 minutes. At that height, it generated 385 kilowatt-hours of electricity, becoming the first airborne wind power device in the world to officially connect to a national power grid. This achievement marks a critical step forward. From experimental testing to real-world power generation, how does a flying wind turbine work? Traditional wind turbines generate electricity when wind rotates large blades mounted on tall towers. This system works on the same fundamental principle, with one major difference: the power generation happens in the sky. At high altitude, powerful wind currents spin the turbine blades. The generated electricity is then transmitted down to the ground through reinforced airborne cables, where it is safely fed into the power grid. By operating far above the surface, the system avoids many of the limitations faced by ground-based wind farms. Why high-altitude wind power matters? Experts believe this technology offers several key advantages: stronger and more consistent wind speeds, minimal land use on the ground, simpler structural foundations, lower environmental and noise impact, greater flexibility in deployment locations. Unlike traditional wind farms, this system does not require vast open land, massive concrete towers, or extensive ground infrastructure. This makes it especially promising for urban regions, mountainous terrain, and areas where space is limited. Successfully connecting this system to the power grid marks a major transition. From laboratory research to engineering scale application, China's breakthrough demonstrates that high-altitude wind energy is no longer science fiction, but a practical and scalable energy solution. Researchers also suggest that this airborne platform could evolve into a multi-purpose aerial system, supporting future applications such as atmospheric and climate monitoring, emergency communications, temporary power supply during natural disasters, high-altitude sensing and data relay. A new direction for clean energy. As the global demand for clean and reliable energy continues to grow, technologies like this flying wind power system may change how electricity is generated, not anchored to the ground, but harnessed from the sky.